we've lost 3 days out of this unit because we had 2 snow days last week and we had a snow day this week. Okay? So because of that, I am temporarily suspending Fridays is assessment day. Okay? So today we're going to learn some stuff. Tomorrow is a regular class teaching type day. Okay? Monday will be notes and a formative assessment on Monday. Okay? Then Tuesday you don't have, most of you don't have class, all of you don't have school because you're doing stuff. So I have nothing planned for Tuesday because we wouldn't normally have class. So ACT day, you don't have to worry about screen. Okay? Then Wednesday, Thursday, Friday of next week is going to be, all 3 of them are going to be notes days, with Friday also being like a formative assessment at the end. So it's a shorter formative and such. Okay? Then the following week is the last week before spring break. And so my plan right now is to have the test be on the Friday before spring break. By doing that, it fits everything that we need to get in with this stuff, because lots of this unit is on the final. It's on your second semester final. I think there's at least 5 questions on this stuff. So, and there's only 15 total questions. So, do the math. Okay? All right? Now, the nice part is that you did a good sized unit on this stuff back in Algebra 2. Okay? We're going to be talking sequences and series today. Today we're going to be talking arithmetic. Tomorrow we'll be talking more arithmetic. Monday we'll be talking applications of arithmetic, sequences, and series. What I mean by that is word problems. Everybody loves them. Okay? And then we'll dive into geometrics, and then we'll dive into infinite geometrics. Okay? So, this slide right here is there's a lot of words and stuff on it. You don't have to necessarily write everything down off of this slide, but I'm going to talk through this slide because this is the foundation for this unit. Okay? The terminology, lots of terminologies are on this one. Okay? So today we'll talk sequences. Tomorrow we'll get into series. The only difference between a sequence and a series is a sequence is just a list of numbers. Okay? That's what a sequence is. It's a list of related numbers. Okay? Meaning there's a pattern to them. They're not just random. A series is the total of them. So you add all of those together. That's the only difference between a sequence and a series. Okay? Sequence is just the numbers. Series, you add them together. And you're finding the sum. Okay? Each individual number in the sequence or the series is called a term. So a term is an individual part, an individual number within that related sequence series. Okay? There are 2 different kinds of sequences. There's finite sequences, which have an end. A finite sequence has an end. The first 7 terms that follow this pattern. Okay? That's a finite number. There's only 7 terms. Then there's infinite sequences. Infinite sequences go on forever and ever and ever and ever. Now, these three dots right there tell you that that pattern continues with nil end. You could have a finite sequence that goes like 2, 4, 6, 8, 22. That is still a finite sequence, even though the three dots are there. That's just saying in this particular, in the green case, it's saying that that pattern continues until you get to a term that is equal to 22. In the blue case over here, that's saying that that pattern continues forever and ever. Okay? So it's kind of the dual meaning of those three dots. In the green case, it's a space saver. So you don't have to write out every single term. So if a sequence has a pattern, that pattern is called the rule. That pattern that the numbers all are aligned to is called the rule. Now you can write the rule in function notation. Oh, you know. We can write the rule in function notation, or you can write the rule in terms of, for lack of a better term, we're just going to call it the rule. It's the equation that follows through. Some people call it the explicit formula. Some people call it the, oh God, what's the other one? Explicit and, I forget, because I don't use the term. Okay? I just call it the rule. Okay? But it's the pattern that follows through. Any questions on the terminology that we're going to be using throughout this meeting? All right, let's move on. Some questions will just flat out ask you, what are the first 4 terms in the following sequence? Side note, if you see an A and a sub n, and that is A sub n, this right here is A sub n. The A stands for that this is an arithmetic sequence. If you see a G, that's going to be a geometric sequence. Okay? So A's and G's there, and they are different. So if I'm asking for the first term of this arithmetic sequence, that would be A sub 1. Not A1. It's not what we put on our steaks to make them taste a little tangier. Okay? It's A sub 1. And what we do to find A sub 1 is we put 1 in place of n in our rule. This part right here is the rule. The pattern, if you will. 2 times 1 is 2, plus 5 is 7. So A sub 1 is 7. That is the first term in my sequence. Now I need to find the second term. What do you think I'm going to do for the second term? It's A sub 2. Yep. And so how do I find it? Plug 2 in for n in my rule, right? Okay. So 2 times 2 is 4. plus 5 is 9. Third term, a sub 3. See the pattern in the sequence yet? What's the pattern? Adding 2. Okay. So a sub 3 should be 11. Two times 3 plus 5, 11. So it works out. So we're adding 2. So the nice thing is once you've established what the pattern is, wink, wink, nudge, nudge, did you figure out where it is in the rule? The pattern? In the rule. Where is it? We got a special word for it. It's a C word. The coefficient. It's the coefficient on the end. This is what you are adding every single time right there. In an arithmetic. Because in an arithmetic, you're always adding. A for arithmetic. Right? You're always adding. So then the fourth term would be plus 2, which is going to be 13. Now, I'm okay with you giving me that as your answer. I'm also okay with you giving me that as your answer. In a list. Terms in your sequence are separated by commas. In a sequence. In a series, terms are separated by additions. Okay? Based off of that, you now find me the 4th, the 9th, and the 32nd term in that sequence. Negative 2 times 4 plus 4. Negative 2 times 4 is negative 8. Plus 4 is negative 4. I get negative 4 for the 4th term. Ninth term. It's going to be negative 18 plus 4 is, I got negative 14. Second term. Negative 64 plus 4 gives me negative 60. In this particular one, you cannot just give me the 3 numbers. You can't just give me negative 4, negative 14, and negative 60. You have to assign them to what term they are. Okay? Nor could you give me just a list, negative 4, comma, negative 14, comma, negative 60. That doesn't work either because they're not sequential terms. Okay? Meaning they're not 3 consecutive. Okay? Another classic type problem in this building is a tall brick building has a decoration as shown. Each row is 1 foot tall. How many bricks would the bottom row, if the wall, or how many bricks would be in the bottom row if the wall is 15 feet tall? And how many total bricks would it take to build the wall? Okay. So we can answer the first one in a couple of minutes, answer the second one tomorrow if we didn't want to do the long one. Okay? Okay. So this is a classic type, like if I'm looking at Monday's formative next or 2 weeks Friday's test, I'm looking at this. This would cover an example like this or a question like this would cover both sequences and series. Just so you know. Okay? So an arithmetic sequence is a sequence that has a constant difference between two terms. Meaning, if you're given the fact that you have two sequences, you need to look and see if whatever change you had by addition or subtraction, because subtraction is really addition, you're adding a negative, that difference there is the same as that difference there, is the same as that difference there, is the same as that difference there, and so on and so forth. Okay? So to go from 3 to 7, we add 4. So 7 plus 4 is 11, which is what we have. So we're good so far. 11 plus 4 is 15, so we're good so far. 15 plus 4 is 19, so therefore this one is an arithmetic sequence. Because this right here is the same. If any of those differ, it is not. Okay. The 3 dots at the after the 19 state that this pattern would continue, so it would stay there. Second one, 20, 15, 10, 5. Is that an arithmetic sequence? Okay. What is the constant difference? Subtracting 5. So the constant difference would be negative 5. Okay. You tell me which of those 4 is arithmetic. If it's not arithmetic, just tell me no and explain to me why. Okay? Go for it. Do it on your own. Yes or no in A? Yes. What's my constant difference? 10. Always going up by 10. So this is plus 10, plus 10, plus 10. So that's my constant difference. So yes, this one is arithmetic. B, yes or no? No, why not? So here it was plus 3. Here it was plus 5. I don't even have to go any further because those two aren't the same. So it's not arithmetic. Okay? That's got to be the same if it's arithmetic. C, yay or nay? Nay. Okay. Here it went, what's that, minus 9? Here it went plus 18. Okay. So that's a no-go there. D. Yes? Constant difference? Minus 12. adding and subtracting. Today, tomorrow, and Monday. So, this is important for you. Okay? This is the arithmetic rule that you will use to write an equation. There are 4 parts to said rule. Okay? So a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub n is the last term, or really, it's any term in the sequence. Okay? A sub 1 is the first term, the very first term in the sequence. We got to have a start. Okay? N is the number of terms in the sequence, or the term number that you're looking for. And D is that constant difference between consecutive terms. I also draw your attention to the fact that if you notice, you've got N there and N there. So if you're looking for the 32nd term, N would be 32 in that equation. If you're looking for the 84th term, N would be 84. Okay. Okay. Everybody good on that? All right. So there's going to be 3 different styles of problems that involve writing an equation, writing the rule for a sequence, then finding some term in that sequence. Okay? The first one, the first style, is going to be given the start of the sequence. Okay? The next style is you're going to be given a specific term and the common difference. And the third style I might have saved for tomorrow. Yep, I did save it for tomorrow. The third style is you're going to be given 2 terms somewhere in the sequence. Okay? So 3 different styles of problems that you can, when I'm asking you to come up with the rule, come up with the pattern, etc. Okay? Or I could simply say, find me the 108th term in this sequence. And it's easier for you to come up with the rule, plug in 108, than it is to try and write out all 108 terms in the sequence. Okay? So how we go about doing this is we use our rule. I'll do the left one. You guys get to do the right one as practice. Okay? So this is my first term. Agree? Easy to find these, you know why? The first one that comes, first one in the list. Okay? All right? My common difference is going to be what it takes to get to the next term. In this case, that is plus 2. So that's going to be my D. When you're making the rule, N stays N. Because you're trying to find the rule to find any term number in there. So, how this would work out is we would have A sub N equals A sub 1. Let me just rewrite this here. So we would have a sub 1 as 1. N is going to stay n. Minus 1 is going to stay minus 1. And my d is going to be 2. Now, ideally, I would allow, I'm not a monster, I would allow this as an answer. If you take that common difference and you put it in front, that works. Okay? I would allow that as an answer. Ideally, though, you would take and you would distribute and simplify. Either one of those would be the rule. They're both the same. Okay. Then, now that I have the rule, now I need to find the 20th term. So I'd have a sub 20 here equals 2 times 20 minus 1. 2 times 20 is 40. 40 minus 1 is 39. Which is a lot easier than trying to write out and count out, okay, the next one's 9, that's my 5th term. Then 11, that's 6th term, and so on and so forth. Okay? Questions on that? You find me the rule and find me the 20th term in the start of that sequence for letter B. So n is equal to 6 is my first term, plus n minus 1. Now, I will tell you that if you write it like that, if you give me that as an answer, you are wrong. Because you are subtracting 4 the way you have it written. You're not multiplying by negative 4. If you write it like this, I'm okay with that. Okay? There is a difference with or without the parentheses. Without the parentheses, it's going to get marked wrong because you're subtracting. Okay? Ideally, you just write it like that. Even better, you write it like that. And then the 20th term would be -7. Questions on that? Okay. Second style, So now you're going to be given a specific term somewhere in the sequence. You'll be given the common difference. Okay. So again, if I start this one by remembering my rule, the generalization of my rule, a sub n is going to be a sub 1 plus n minus 1 times d, I know that this is the sixth term in there. So I can make that be my a sub n. I don't know my first term. But if negative 16 is my sixth term, then n is 6. And d is 9. 6 minus 1 is 5 times 9 is 45. So this becomes negative 16 is a sub 1 plus 45. Subtract 45 from both sides, and I get negative 61 is my first term. Agreed? Okay. Now I can go back to that, and now I can say my first term is negative 61. My common difference is 9. Scroll down just a little bit. So now I can say that my nth term is negative 61 plus 9 times the quantity n minus 1. Or I can say that 9n minus 70 is that, if I were to distribute. Either one of those works for me. And then I believe it said find the 18th term. It did say find the 18th term. So then we would say a sub 18 would be 9 times 18 minus 70. 9 times 18 is, I believe that's 162. Minus 70 would be 92. Yes. Okay. You try that on this. Three is going to be the first term
minus 77.
12 minus
11, that's -7. So I get 74. That's the first term. So then A sub n would be 74 plus n minus 1 negative 7.
either one of those. And then we need the 18th term.
Oh my God, 7 times 18 negative 126 plus 1 is negative 45. Yeah? Yes?
No, maybe. Again, you don't have to give both of the recursive or recursive. Recursive or explicit. That's the one. You don't have to give me either one of those. You just gotta give me one. Doesn't matter which one you give me. On my answer keys, I have them both. Questions, comments, concerns, clarifications?